Okay? The empirical rule says on a bell-shaped curve, if it's a bell, within one standard deviation lies 68% of the curve. Within two standard deviations lies 95% of the curve. And within three standard deviations lies 99.7% of the curve. Okay? Now, let's go over here. We'll redraw that picture. This is 80, 90, 100, 70, 60, 50, 110. Okay, now, here's 80. Within one standard deviation, and again, of the mean, you should think of the x bar, or of the mean. Here's the mean. Within one standard deviation. Now, 1 goes like this. 1. Within 1. Remember, I'm the mean within one standard deviation of me, either way. Okay? Within 1 standard deviation lies how much percent of 68% of the curve. Okay? And let's just extend these bars all the way up. Now, within 2 standard deviations lies 95% of the data. Okay, within 2. And if you get all the way to 110% to 50%, we should expect 99.7% of the data. Okay, 99.7% of our observations should fall 3 standard deviations between the mean. Okay, so that means 3 standard deviations to the left and 3 standard deviations to the right. Okay? 99.7. Now, that is if it's a bell. If it's a bell-shaped curve and it's symmetric, this empirical rule will hold true. Okay? But, what if it's not a bell? What if it's skewed? And in this case, it's skewed right. It's skewed to the right. Okay? Skewed to the right. Now, if it's skewed to the right, where will it balance? Okay? Where will it balance? Well, you realize that the mean is going to be here with the majority of the observations. Excuse me. Let me think about where it will balance. Now, remember, this mean is going to go with those outliers. The mean is going to go with your heavy observations. You're going to have to scoot the mean out a little bit to balance. Okay? So the mean will be to the right. The median will go in the middle of a lot of the observations. You can see that a majority of our observations will be here, so the median will tend towards the majority of the observations. And the mean will go to the heavy observations. Now, if that just didn't make much sense, think about this. Little rule. The mean chases the tail. Okay? The mean chases the tail. If the mean is to the right of the median, you know that your distribution is skewed right. Conversely, if you would find that the mean is left of your median, you would know that the distribution is skewed left. Okay, because the mean goes with those outliers. The mean is heavily affected by outliers. The median will always be in the middle. But the mean is the balancing point. It's the fulcrum on your teeter-totter. Now, these are skewed observations. Now, let's go back. This is not a bell. Okay? So the empirical rule, it does not hold. Okay? The empirical rule does not hold But we have a skewed distribution. It's not a bell. Okay? So we cannot use the empirical rule, but we do have a rule, and it's called Chebyshev's rule. Okay? And Chebyshev's rule is there on page 121. And it tells us that we know within one standard deviation on any curve you can draw, skewed, right skewed, left skewed, symmetric, whatever, we know within one standard deviation of the mean, we are guaranteed lies 0% of our observations. Okay? Not a lot of information. But within two standard deviations lies at least 75% of our information. So, no matter what curve you can draw, I know that if you give me two standard deviations, I can get you at least 75% of the data. And 3 standard deviations is 88.8. In your book, actually, I'm checking, your book has 88.89. So it takes it one step farther. 88.89 within 3 standard deviations. No matter what curve you can draw me, what distribution you give me. Chebyshev's rule. Okay? Now, that's pretty interesting, I think. I think it's very interesting. You are going to be given numbers on your homework, a set of 5, maybe 6, maybe 7. Okay? You're going to be asked to find the mean and the median. You're going to be asked, is it right skewed or is it left skewed? You're not going to have the picture. You could put those numbers in the BHStat, make a histogram. You'd be able to see it just like that. If you didn't do that, you could know the mean chases the tail. You're going to know if the mean's to the right, it's skewed right. If the mean's to the left, it's skewed left. And when I say to the left, I mean to the left of the median. Find the median, you see which way the mean goes. That way, if the mean and the median are together, you know it's symmetric. Okay? It's not skewed. Now, you're also going to be given a list of numbers and asked about Chebyshev's rule, or the empirical rule. And you're going to need to know that. And finally, we have z-scores. Z-scores. Z-scores can tell us exactly where we are in relation to the mean on a bell. Okay? So we're back to a bell. Just to have that picture in your mind, I'll put it here. There's the bell. Now, a z-score will tell us where we are relative to the mean. Let's go back to 80. Now, we know 80, 90, and 70. Within 90 and 70 is 68%. Between 100 and 60 are 95%, should be, of our observations if we're on a bell. And between 110 and 50% lie 99.7% of our observations. Okay? But, let's say you got a 95. Well, exactly how many standard deviations are you away from the mean? You should be able to tell from this picture. 90, 100. Well, this is 1 standard deviation. This is 2. If you got a 95, let's use the formula, but I hope you should be able to figure that out. Let's look at the formula. Z equals x minus x bar over standard deviation. Okay? Over standard deviation. Now, x, not xi, but x. X is your observation. We're not counting, we're not going to do yours and your classmates. No, just yours. Your observation. Okay? Doesn't have to be a grade, but it's the observation you're testing. Generally, when we're talking about tests, we're testing our score. But maybe you're talking about melting metals. Yeah? And you're looking at the melting point of aluminum. Not xi, just x. Okay? So x minus x bar is the average over s. S is the standard deviation. Now, in this situation, you got a 95. The mean, I've already said, is 80. And we know the standard deviation, again, remember the standard deviation is 10. So your z-score would be 1.5. Okay? 1.5. 1.5. Now remember, what the z-score tells us is how many standard deviations away from the mean you are. Okay? There are two components to a z-score. First, the sign. This tells us direction. Okay? 1.5 in the positive direction. Now, imagine you are right here. You're at 1.5 standard deviations away from the mean. Okay? And we're going to use z-scores a lot in chapters 5, 6, and 7. Okay? Now, just to get the hang of it.